Welcome back to science class. We're going to keep talking about Earth science this week, and we're going to focus on the Earth's layers. So we're going to keep going with our Cornell Notes model just because it's easy enough for you to do at home. So you're going to set up a blank page in your notebook as you have been doing for the past couple weeks if you've been keeping up with your notes. So the final elements will look like the example on the left. But for now, just set up something basic, like what's on the right. Add your page number in the corner, whatever page number you're on. You can just use any old piece of binder paper if you don't have your science notebook. Put the title on top, or its layers. Leave yourself a spot for the EQ, and when you're done writing the EQ, just draw a line like that underneath it, and then do a line going down. Don't go all the way down because you don't know how much space you're going to use. And I usually lay about 3 fingers right there, and that gives me enough space. So go ahead and pause and set that up. Okay, so the title of the lesson is Earth's Layers, so put that on top if you haven't already. And then here's our essential questions. What are the main characteristics of the Earth's layers? How can Earth's layers be illustrated? Go ahead and hit pause and write down the full EQ. All right, now in the main body of the notes on the right-hand side column, we're going to add this simple diagram. Don't make it huge. Maybe you should take like, I don't know, about 4 lines of your notebook. Just draw a circle with some inner circles and add the labels to it. So as we go through each of these layers of the Earth's crust, you'll have an idea of where they belong. So go ahead and hit pause and copy this diagram down that you see right here on the left, including the 4 labels. All right, we're going to work from the outside in. So we're going to start with the crust. So just listen, and then I'll tell you when to pause and write down the underlined things. So it's the outer layer of the Earth. If you think of an apple, the crust would be the skin of the apple. So it's really, really thin. It's made up of continental land crust and oceanic crust, which is the stuff underneath the ocean. And it's about 5 to 50 kilometers thick. So it's pretty thin in relation to the entire Earth. So go ahead and pause and copy down the underlined things in the body of the notes section on the right column. All right, so last week we talked about what happens when these chunks of crust run into each other, the different boundary types, the mountains and volcanoes and things that they form. This is just a little review. So there's 2 flavors of crust. There's oceanic crust. It's underneath the ocean. It's really thin. It's more dense than continental crust. It's made of a rock called basalt, and it's thinner than the continental crust. It's also younger than continental crust. And then we have continental crust, which forms the land. It forms the continents. It's less dense than oceanic crust. It's mostly granite, and it's thicker than that oceanic crust, and it's also older. All right, let's keep diving down. So our next layer is the mantle. It is the largest layer of the Earth. It's kind of hard to tell in this little diagram. It's not the best little diagram, but the mantle is the thickest layer. It's under the crust, and it goes to about 2,890 kilometers below the surface of the Earth. And it's made of silicate rocks that are rich in magnesium and iron. Intense heat causes those rocks to rise and then cool and sink. So we talked about that last week with the convection currents that drive the motion of the plates. So the average temperature is about 3,000 degrees Celsius, which is pretty darn toasty. Go ahead and hit pause and copy down those notes about the mantle. Everything you see underlined. Okay. Now here's where it gets a little confusing because we have this layer called the lithosphere, and it exists. It includes the crust, the rocky layer, the outer section of the Earth, and it also includes the top part of the mantle that's cool, dense, and rigid. So here we see it right here. So we got the crust on top here, and then kind of like right underneath that is the lithosphere. So the lithosphere includes the crust and the very, very, very top cooler layer of the mantle. So go ahead and pause and write that down. And then below that is the asthenosphere, which I can never say right, the asthenosphere. So it's the solid part of the upper mantle. It's like the consistency of silly putty or really thick toothpaste. So it can move, and it moves over the plastic. The crust moves on top of this plastic-like asthenosphere. And this is what causes those plates to crash into each other and pull apart from each other and grind past each other and all that kind of stuff that we talked about in the last lesson. So in this example here, we have, the lithosphere is on top of the asthenosphere, and the asthenosphere churning around kind of like pulls the lithosphere, and we have a subduction zone happening here, creating volcanoes like that are in Northern California and go up through Oregon and Washington. So go ahead and hit pause and copy down the notes about the asthenosphere. Okay, now it's time for another drawing. So do your best with this. Don't worry about it being perfect. Even if you don't include this top part, making it more 3D, even if you just kind of do this cross section right here, but go ahead and label where the crust is, where the lithosphere is, and where the asthenosphere is. And add this into the body of your notes. So pause and make it happen. All right, let's dive down deeper, shall we? Let's get to that outer core. It is liquid. It's 2,300 kilometers thick. It's the second largest layer on the Earth. It's made of liquid iron and nickel. It's between the inner core and the mantle. And it moves. It's liquid, it flows, and it goes the same direction that the Earth rotates. And in the next slide, when I talk about the inner core, I'll tell you why it actually creates the Earth's magnetic field. So go ahead and hit pause and copy down those things about the outer core. Oh yeah, and the average temperature is between 4,000 to 5,000 degrees Celsius, so it's getting hotter as we move closer to the center of the Earth. All right, and our very last layer is the inner core. It is solid, which is really strange. Most people think that, it's liquid, but it is a solid ball of metal. It is about 1,200 kilometers thick, and it's made of solid nickel and iron. It's so hot, it's hotter than the surface of the sun. It melts everything in the outer core. So you might be thinking, okay, well, if this is solid and it's so hot, it's melting all this and making it liquid, then why isn't this liquid? It's because it's in the center of the Earth and it has all the layers of the Earth pushing down upon it, and it's at such high pressure that it keeps it solid. It doesn't allow it to melt and slide around. All that pressure just keeps the atoms so tightly locked together that it makes it solid. It actually spins too, and it spins faster than the Earth's rotation, and it rotates in the opposite direction of the outer core. So we got the inner core spinning, actually it'd be spinning this way, and we got the outer core spinning this way. And whenever you have two metal things kind of wrapped around the other and you get them spinning, you can create an electromagnet. So that's actually why the Earth has its own little magnetic field, is because of it being solid and spinning in opposition of the outer core. It's the densest layer of the Earth, like I told you before, and it is so hot. It's between 5,000 to 6,000 degrees Celsius. Again, that's hotter than the surface of the sun. So go ahead and hit pause and copy that down. All right. So you might think that scientists know about the layers of the Earth because they've been there, if they've dug down into them and seen them and sampled them. And that's actually not true. The only layer of the Earth that humans have dug down and explored into is the crust, which is the thinnest, topmost layer of the Earth. So how do we have any idea of what's going on in those other layers, what they're made of, if they're solid or liquid, what their temperatures are? It has to do with seismic waves. So seismic waves are caused by earthquakes and other rock movement, and they travel through the layers of the Earth. And we can record them with this little thing right here, which is a seismograph. So if it's cruising straight, that means nothing's going on, but we get this little shaky here, that means an earthquake has happened. All right, so say we have an earthquake that happened on this side of the Earth right there. And we can have little seismographs, and there are seismographs all over the world at different recording stations. So here we have an epicenter of the earthquake where the earthquake happens, and then we can have a seismograph over here picking up. And so we take the data from all the seismographs around the world and track how the waves from one earthquake have moved. We can see their motion. And based off their motion of, how straight the lines are, how much they bend, if they crisscross, things like that, that tells us the density of the materials that they're traveling through, if they're solid or if they're liquid or things like that. And so scientists have used all these clues to determine, what the layers are, if they're solid or liquid, and what they're made up of. All right, ready for a little cheesy science song? Layers of the earth. Layers of the earth. Throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Yeah. The layer we'll discuss first is the central inner core in the center of the earth, a solid ball buried below the dirt.
We believe it's primarily metallic iron.
You can never take a trip to the inner core, right? The heat will burn you up 9,000 Fahrenheit, 4,000 miles below the Earth's crust. One down, three to go, y'all. 1,800 miles from the tip top. The outer core is hard at work and it don't stop. It's busy spinning around the inner core. And listen, this steady movement causes Earth's magnetism. Ranging from 4 to 9,000 degrees, it contributes 1/5 of the heat flowing to you and me. It's liquid metal that violently flows. So let it settle when you're ready, let me know. Just throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Yeah. The mantle layer is the largest of the class, about half of our planet's mass. The mantle is composed of very hot, dense rocks that move and flow, always on the go. They never lie, never stop, and responsible for tectonic shift.
Please believe.
Earth's plates are adrift. It's pretty thick, y'all, and the heat is awesome. 1,600 at the top, 4,000 at the bottom. The continental crust surface is where we breathe. A lot of rock up to 25 miles deep. The oceanic crust is just next door. It's 3 to 5 miles thick below the ocean floor.
Earth's surface.
70% H2O.
Where you get all that water?
Salty sea flow. The rest is fresh water in the glaciers, ice caps, and snow. Let me see you throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Yeah, I know you're dancing. I can see you. Haha, not really. All right, so back to the notes. Yeah, best part. Okay, now it's that time with Cornell Notes where you revisit them. So you should have the title, you should have 2 diagrams, 2 drawings, you should have all the underlying notes from the slides. I want you to go back through, reread everything, underline or highlight anything that jumps out to you as important. And in this column over here, you're going to write down any lingering questions that you have. I always enjoy looking at those when you send me a picture of your notes. Main ideas that pop out to you, vocabulary, like, you could have it labeled like crust, mantle, inner core, outer core, things like that. And you should have at least 3 things happening in this column. So go ahead and hit pause and actually revisit those notes. Okay, last but not least, it's summary time. So in that bottom section there, you can use this scaffold. The Earth has 4 main layers, so write that down. And then I want you to describe each layer in your own words. So don't worry about recopying everything from your notes, but you should be able to tell me something about the crust, the mantle, the outer core, and the inner core. All right, that's it. So go ahead and pause, copy that down, fill it out, and then remember to text or email a picture of your completed notes to your teacher. See you next week and keep learning.